another LeetCode Path to Pro video. It's been a couple days. I was doing OAs and then I had some car stuff, but we're back. It is Saturday, November 18th, 11:50 a.m. Yeah, I don't have too much time, but we'll try to do this one that I still struggle with, and then we'll maybe start on one of the binary problems. Cool. Let's do it. So I think it's this one, search and sorted array. Right. This one's tricky. 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 Let's get that out of the way. All right. So search number 33, search and sort array. I think this is the third time I've tried it. There's an integer array nums sorted in ascending order with distinct values. Prior to being passed to your function, nums is possibly rotated at an unknown pivot index, such that the resulting array is blah blah blah. Right. So we want to return if it's in nums or -1 if it is not in nums. So this is binary search, right? O of log n, it's binary search. So we got left. So let's kind of go through the binary search. Right, length of nums. That's one. No left, less than right. Let's say if, and then we got to calculate mid. Mid equal target, we can turn mid. Otherwise, we have to do some stuff, right? Else if, and basically, I watched that LeetCode video a couple of days ago. We have to figure out what part of the sorted array we are in, right? So this is nums. 6, 4, 5, 6, 7, 0, 1, 2. Right. So left, right. So we need to figure out, okay, if mid we need to figure out which part of the sorted array we need to go to, right? Where it is. So else if I think it's like nums of L less than right, we need to check, okay, if target is less than nums of mid, but it's greater than nums of L, right, meaning it's kind of in here. What do we want to do? We want to set right equal to mid, right? Else, we know we're going in the other direction. We can say else if nums, otherwise, right, nums of R copy this. Gotta log in. Don't look, guys. See my login. I guess you might be able to. That's good. Please don't hack my code. Okay, so now we need to check. Okay, if num's a mid, it's greater than target. The target is R. Right, we need to say left equals mid, else right equals mid. That's fine. And then we could just return -1 out here. Okay, so we're doing something wrong. How do these work? Let's see if it only works for ones where we're changing. Looks like we get -2. Okay, let's think about this. So let's switch up to this. Let's try. Quick fix. Let's see. No, doesn't look like it. That even breaks it. Well, passed a couple more test cases. It's kind of cool. So we're calculating mid. We want to say if nums of L is less than nums of mid. So we're looking over here. Right. If nums of L let's say if nums of L less than or equal to target. Maybe this is the issue. Right. If nums of L less than or equal to target, and target is greater than nums of L, so that means we're over here. We want to set right to mid. The other case, right, would be over here, so we want to set left to mid +1. Right, because we're already checking mid. That's why we can set left to mid +1. Here, because here the problem would be yeah. Okay. Say otherwise. So what? I guess we'll do the else if, just kind of explicitly show what's going on. So if nums of what's the other case? Nums of R is less than nums of mid? I feel like we need to rewrite this. So this case would be like this, where we have 5, 6, 7, 0, 1, 2, 4, left, right, mid. So now nums of R is greater than nums of mid. If nums of mid is less than the target is greater than nums of mid, it's less than nums of R, that means we're over here. We want to set left to mid. Else, we'll just add these, equals else right. Otherwise we're over here. Okay, I mean that makes sense to me. Clearly I'm messing something up still. I think it's in these original checks. I don't want to spend too much time on this. Yes, we're still messing that up. Else. Maybe just try like that. What if we just keep this else? Passes less. This problem's so tricky. Okay. All right. All right. Guess we do have to do less than equal to. Maybe that's our issue. No, it's not. Damn. It's frustrating. What's going on here? We have to. That. Nice. Ha! Sweet. Okay, we did it. It's so slow though. Okay, there we go. It's so wild. Like, you see this? I mean, this is the same memory it's listing, but this one was like 40.7%. That was like 9.63. Because it's probably like 16.7 rounding up to like 6.7 something, and then 16.7 like 7.2 versus 16.74 or something, you know. And then the speed. Okay, awesome. Fuck yeah, nice. Let's see how similar this is. This interesting. So it's a different solution that I came up with. That's kind of cool. Let's take a look. Let's compare these. So doing the same, setting left and right, checking while this is doing only left is less than R. Right. Because they're doing a special return, so returning left if that's L equals target else. Interesting. So that's how they're handling the case, that 1-3 case. Okay. Or that's how I was, I guess. Yep, else if nums with L. I'm doing less than equal to nums with mid, greater than nums with L. Okay. Huh. Oh no, we're doing the same thing. Same check here. Yep. Yeah, basically the same. Okay, so it is like similar. Cool. Really stoked about that. I was nervous today about this problem and not being able to do it. I mean, look at that, right? Like, now it's like, oh, this is, 98.84% fastest solution. So, it just, I don't know, it changes. I don't really know why. But yes, finally did that. Nice. Get that out of the way. Maybe I'll do a marathon sometime next week and just go through all the problems I solved. I think for a binary, I should probably start with one of the easy ones. Yeah. Where the fuck should I use it? I might. I might just like, I think I need to do a little course on binary before I try these, because that's just going to be nonsense. So I'll come back to these when I've done a little course. Let's go ahead and do the first DP, because that's something that I feel a little more comfortable with. So we're playing. Oh, DP is so very hard. Let's fold it up. Alright, so I'll give you options to read it. Okay. Excuse me. So, so you're climbing the staircase. That's n steps to the top. Each time you can either climb 1 or 2 steps, and how many distance? So n equals some number. How many distinct ways can you climb to the top? Okay, so I know of like 2 DP. DP is all just about like dynamic programming. It's all just about finding like the smaller problem within the problem. Right? The problem here is like, okay, how many ways can we get to the top? But the smaller problem would be like, how many ways can we get to like the next step? You know what I mean? I don't know. I'm not that good at the DP stuff still, but yeah, let's give it a shot. So let's say in a case, let's do something more interesting. N equals 4. Right? We can move 1 step or 2 steps. So that's gonna look something like this, right? Where it's like 0, 1, 2. Kind of lost. Alright, so we're starting like, disappeared. So we're starting like here. You know, this is your start, right? So you can climb 1 step or 2 steps, right? So we can be here. Oh, I gotta climb 3 steps. Jeez Louise. Or we can be like here at 2, right? And then from 2, right, we can climb 1 step or 2 steps. Right, so we can end here or here, and we can be done. Right, so maybe a better way to visualize this would be something like this, where we start here. So we can go 1 step or 2 steps. From 1 step, we can again go 1 step, so now we're at 2 steps, or we can go 2 steps, now we're at 3 steps. From here, we can go 1 step, we're at 4. From here, we can go 1 step again, 3, or we can go 2 steps and be done. From here, we can go 2 steps, end at 4, or we can go 1 step, end at 3. From here, we can go 1 step again, get to 4. From here, we can go 1 step again, get to 4. So if you'll notice, we are doing some repeated work here, right? Like, look, a good example is like this 2, right? We've gotten to 2 steps before for both of these. And we know what these paths look like, right? So we know what those paths look like. Right, so we don't want to just do that work again. Oh, DP's so hard. Such a hard. I think let's do it. Let's try with the DP array. Alright. So we have DP. And we set DP to 0, times the length of n, right? We loop through dp backwards. Step in. dp. Right. What do you want to do at each step? Right. So if we're at 4, right? How can we get to 3? Oh man, I have no idea how to do this. Let's try doing it. This is like trying to do it bottom up. Let's try doing it top down cursive. So define step. I just want to pass in. And just press total. Is it total equals 0? Okay. Yes. So if we like, just trying to think. Do the temp. Do we just call step on total? You say count. Count. And then we next equals step total this one this 2. I don't think this is gonna work, but Yeah, it's gonna cut a loop. This never gets called. Okay, timeout already. Wait, we're ready. Oh man. Good. Outside loop. Is that me? Oh, yeah, sure. It's not though. Put it up here. Huh? Look who's count. This fucking bug. There it is. What? Count is up here. We have to put it down here. Do we want to put it here? We have to pass it in. I think we need to mess it in, yeah. Set total. Count. Okay, yeah, so it's not gonna work. I don't know how to do this, so we're gonna look. Let's see. So this looks pretty easy. Little solution. So if n is less than or equal to 3, return n. Yeah, okay, that makes sense. 1, 2, put them both to 1 for I in range. And minus 1, temp equals 1. So let's try to keep track of this. Let's try n equals 5, right? So we're going for 0. We're going to do this loop 4 times, right? I think. Oh, we don't want to submit it because then it'll just. open to okay, yeah, so it's gonna run 5 times. Okay. So I was gonna go through 0 through 4. Oh wait. Wait, did it not give us? Did it not give us I? Why is it not giving us I? Oh, duh. That's 'cause of that. Never reaches this though. Yeah, okay, so that's 5. That's what I thought. Okay, so it's gonna loop through 4 times. It's like a sanity check. Okay, so it loops through 4 times in this case. 0. Let me do this. Because this code is confusing. Ah, shit. Oh. uh, it's what if we made, we say n equals 5? What? Doesn't help me at all. Okay. So it's here. What will this do? Okay. So this will go 0 through 4. And then we say temp equals 1. So temp equals 1. So 1 equals 1. I guess these are like the steps you make. 2 equals 1, right? Then 1 equals 1 plus 2. So it's 2. 2 equals 10. 2 equals 1. So we took 1 step. Very nice. Alright, and we're done with. We got 0, 2, 3. Done 1. Set temp to 1, 2. 1 equals 1 plus 2, 3. 2 equals 2. Okay. Done with another loop. Temp equals 1. 3. Plus 2 is 5. 2 equals 10. Interesting. Temp equals 1. 5. 8. You see a pattern here. So obviously 8 is the number of ways. You know. Let's see how this works, but that's okay. Like, what are they keeping track of? Temp and 2. I don't know. Oh man. That stuff, but that's all the time I have. Look at that. Quick. Alright, well yeah. I'll get good at these. Don't you worry. I'll get good at these DP problems. Alright. Cool. Thanks for watching, guys. See you soon.